So as we remember, when we were talking about addresses or whatnot, I had a IP address. This based off of my range. Can anybody tell me about this IP address? What can you tell me about it?
Class C.
It's Class C. Excellent. So it's Class C because of its number. Do we know anything else about it?
Are the first three, is it called octets? Is it the first three octets that's for network?
Yep. So the first three would be our network. And then the last one would be our host, right?
Host.
Yeah.
So we know that. So that's another good thing about it. Is there anything else you can tell me about this IP address?
Is it private?
It is a private IP address. Excellent. So CIDR subnetting occurs on your private network. And basically, you had what was called class full subnetting, which was class A, class B, class C. Very clean, you know, breaks it down. So this is a class C, so we know these three are our network, and the last octet alone is our host. And we notate that by /24, correct?
Correct.
So, you know, and then the other way we would write this would be 255.255.255.0, right? So that's the other way we would notate subnet mask. And then the way the computer will see that subnet mask is 1, 2, 3, 8. There we go. Clean that up a little bit. So you or I would either see a /24 or 255.255.255.0. And then the computer sees a string of ones followed by a string of zeros. That's how it knows that that's what you're sending is the subnet mask. Are we all clear on this?
Just to confirm, the 24 comes from the 3 octets below, right? The 255.
Correct.
Okay.
So yeah, there's 24 ones. So that's what that /24 is. So 24 ones. And then we only have 8 zeros left. So it's followed by 8 zeros.
And the beginning address, how do we find out it was a type C? Because that's the part that kind of confused me.
Because the first octet was 192. Because remember we had the ranges for the A, B, and C.
Yeah.
And 192 puts us in the range for a type C address. And then the 192.168 puts us in the public address range or private address range, excuse me.
So it's just something we have to memorize from before that you mentioned earlier, right?
Some of those pieces, yes.
Okay, gotcha. All right. I thought I was missing something that like I didn't
Nope,
do a
not
math
missing anything.
conversion.
Not
Okay.
missing anything. Not yet.
Thank you.
So yeah, not missing anything at this point. So, which is fine, you know, so we can break it down into 20, you know, we have up to 255 or 56 spots. They always subtract 2 from the total number because they use the top end is for what's called the broadcast. The first address is for the router. So 192.168.15.0 would be the router. 192.168.15.255 would be the broadcast for that network. Don't need to worry about that part of it yet, but that's what they're doing. So I can get up to 255 or 254 hosts in this network. What if I don't have that many computers? You know, what if I only had 100 computers? Is it practical for me to have 255 addresses?
No.
No. So what CIDR is a classless way to route traffic or to create networks, to break them up into smaller and smaller useful chunks for us as IT administrators. So, and it basically stands for classless interdomain. So it's inside your network, classless interdomain routing, CIDR, classless interdomain routing. And this is a way to kind of break up classes into smaller groups. So say I wanted to create 2 networks inside. So say I wanted to separate research and development away from everybody else. So you have operations and research development, right? So what I'm going to do is I'm going to take an extra bit right here. So you have this long string of ones, and I'm going to take one more bit. And so this will become a /25. So instead of 24, this would be a /25. Oops, 25. And then I'm going to use this extra bit right here for routing in my internal network. Do we understand that? So if I'm using, so I'm basically, for class full, it's a class C. We're only going to focus on this last octet. So everything we do is going to be class C. But I want to break this class C up into smaller groups. So I'm going to say, I'm going to use 1 bit to create multiple networks inside mine. So if I'm using 1 bit, how many options do I have?
8.
No, well, not a byte, a bit. So how many options do I have with a single bit?
255.
No, if a single bit, how many options with 1 bit? What can I do with 1 bit?
On and off.
On and off. So I have 2 options, right?
Oh,
So I have on and off. No, it doesn't only apply to class C for the purposes of this conversation, because I don't really want to get that far into the weeds. We're only going to work with class C just to make it a little easier.
Okay, thank you.
So a single bit, I have 0 and 1 as my options, right? That leaves me now 7 bits for my host addresses, right? So what's the highest I can count to with 7 bits? So I know with 8 bits, I can go to 255. How high can I go with 7?
128.
164.
So 128, right?
Yeah.
It's actually, so it's 0 to 127, and then 128 to 255. So if the bit is off right here, the highest I could go is from 0 to 127. So I get 128 options. I can go from 0 to 127 with the bit being 0. Once I turn it on, that last bit is equal to 128, right? So if you remember from our binary diagram, that last bit equals 128, correct? I'm looking, I mean, am I getting crickets or? All right. Our binary chart.
If you have that, sorry, I had something in. I was eating. All right.
No problem. So our binary chart, we go back to our IB classes over here.
And you went
So-
over to 128, and you only
Yeah,
have
so we
that
have
one value
1.
up.
Yeah.
Yes.
That would
So-
be 128.
If I took this chart here and I only turned on that single bit, it equals 128, correct? See that?
Yeah, sure.
So if I turn that off and I turn everything else on, gets me to 127. See it? So that ANDing spreadsheet I sent you is basically a binary calculator for you to play with. So with the 0 here, I can go from 0 to 127. If I turn that on, I can go from 128, which is that one, all the way up to 255. So in essence, what I've done is I have broken my network in half. I have broken my network in half. So I have 0 to 127, and then I have 128 to 255. So I had a total of 255 before. I literally cut it in half. And now I have two equal networks of 0 to 127 and 128 to 255. Does this make sense? All I've done is taken a single bit and cut my networks in half.
Yes.
So you're pretty much like dividing by 8, right?
Well, I'm
So
dividing it by
because-
2. I'm cutting it in half. That's all I'm doing.
Oh, okay. I meant, but they're all like dividends of 8, right? That's why you're getting, because you're getting the 8 bits originally, right?
Yeah.
Yeah.
I'm only playing around with this last 8 bits. That's all I'm doing. I'm
Just making
only
sure.
playing around with this. So it's a class C. I'm only going to play around with this last 8 bits.
Got it.
So if I take internally in my network, if I take one of those bits and use that for network in my internal network, I can now create 2 networks for bit 0 and bit 1. So I can use bit 0 or 1 for this bit right here. And that gives me a range of host numbers from 0 to 127 for my 0 network and 128 to 255 for my 1 network. Does that make sense?
Yeah.
Okay,
Yes.
good. Because we got to make it more complicated now.
Unfortunately, yeah.
So let's adjust it now and say I'm going to use 2 bits for a network. So this now becomes a /26, which is what you were seeing in your Coursera lab. So we now have our /26. So now I'm using 2 extra bits for networking. So I have 2 bits. What options do I have for 2 bits? So I have 2, just strictly 2 bits. What different combinations can I have?
4.
So I'll start you off here. You got 0, 0,
1, 1.
0, 1, 1, 0, and 1, 1, correct? So I have 2 bits. I can now make 4 networks. So I have my 0, 0 network, I have my 0, 1 network, my 1, 0 network, and my 1, 1 network. So when I had 1 bit, I broke it into 2 pieces. Now I'm going to break it into 4. So my first network would be 0 to 63, 64 to 127. So if you look, I just basically took this network and I cut it in half. That's all I did. And I created 2 more networks with it. And then I'm going to take this network and cut it in half. So I have, is it 164 or 64 to 122? And then I do 190, was that 192 or 191, excuse me? 120,
You said one-
123. Wait. Do what?
You said 164 to 127, you said.
27, yes. So 128 to 191, I believe. And then 192 to 255. So I've created 4 networks, all right? I basically just took the one network, and I broke it into 4 equal pieces.
Kelly,
You know,
I think this just looks a lot scarier than it is.
it is. I mean, I don't know why, but yeah. I mean, it's,
Um,
you're literally just cutting the network in half for each bit that you add.
no, it's just like, yeah, that's the point. But it's like, if you understand subnetting, right, and
Mhm.
what we're doing within these networks, then CIDR subnetting is just
An
allowing
extension
it.
of it.
Yeah, it's just an extension. You made it seem like we were about to reinvent the wheel, man.
Well, some people it's hard to grab, you know, until they work with it a few times, and some people it clicks right away. So let's say I'm gonna leave these up here for now. So here's your /26. And here is your /20. Oh, sorry, 26. This is 25. Apologies. And my penmanship is just horrible. I wish I could say it was better when I'm on paper, but it's actually worse. All right, 20.
Kelly, hold on, Case.
There we go.
Kelly.
Yep.
So /27 would be 3 bits.
Yeah, /27 would be 3 bits. And then you would have, so /25, we have 2 networks, 128 in each network. /26, we have 1, 2, 3, 4 networks, 64 in each. So you're doubling the number of networks and you're cutting the number of hosts in each network in half each time you add a bit. Make sense? Yes, Madison.
Eventually we end up
I was wondering, why would we use this again? Why can't we just leave it whole?
Because we don't necessarily have enough computers to fill it up. And a lot of times we want to break our networks into smaller and smaller pieces. Because you don't necessarily want everybody playing around on the same network. So you can isolate certain things from each other. Like you wouldn't want research and development on the same network as your web server. Because if somebody hacks into your web server, then they would have all of your research and development, right? All right. So let's say we have a /25, which is this right here. Let's ignore, or we can use this one right here. So we know our first 3 are our class full subnet. We have a /25, so we know we've created a broken up our 2 networks. And then these numbers here are our ranges. So if I'm coming in and I have a 192.168.15.27 with a /25, which network would I be in?
The 0.
0.
0, because 25 falls in this range, right? So if I have a 192.168.15.113 and it's a /26, which is this network. So /.126, which network would I be in?
01?
01, yeah.
01.
Yeah.
Is it starting to make sense?
Yep.
Yeah.
So
scared
this
it's an
allows
yes.
it. This is so like when something comes in based off of that last digit, you can tell which network it's supposed to go in. All you got to do is you got to write out your ranges. And it's, again, each time you do it, you're breaking it up. So if it's the /25, you're using the 1 extra bit. You have 2 different networks.
/25 is
Write out
one
your
bit.
ranges. That's it. So /25 is all of these, which is the 24, and then we took 1 extra.
You use
you
the
get the 24.
use the binary chart along with this, and you'll understand it a lot better. It's gonna go from 2, 4 to 8 to 16, 32, and then 64. It's gonna keep going up that way. With the regards to how many sections we can have within that network. So
So-
you use one bit of information, and if it's one, then that means that the only thing that you're using there would be the one, the only thing that's lit up essentially at the front. Am I saying this right?
Yes,
Okay.
yeah, I get what you're saying. So like,
120
if we
is,
come back
yeah, is
here,
128. You know how you have that first one lit up. So yeah, there we go. If it's at 128, then that's where you're splitting it off from. You know, that's where you're splitting it off. And then when you go one more, so it's 1 1, then it would be 128 and 64. And that's where it would split off at. It would split off at the 64, but it's still out of the whole, it's still out of 255.
so
It's hard to say in words.
Okay,
Kelly,
so
please
so
illustrate.
slash
Okay,
25 is 1 bit, 26 is 2 bits, and it goes on
Yeah.
like that.
yeah,
So because
that's all it is.
the
So
other
what I can say is
subnetting
like-
is it stops at 24, right?
No,
So slash
You can-
24 is
well,
the other mask.
that's the only one we're going to be using for this class.
Okay.
So we're only going to use the last octet. You can go another way, but this is just an introduction decider. I don't want to go full blown because the host and network thing can get kind of crazy. So we're not going to do that. So let's say for my last octet, I know what my first one is at 192.168.15. We're only playing around with the last octet, which is this right here. This box right here represents what I'm taking to use for my network purposes. So I'm going to use this grade in box. That's my box. So I'm going to use that to break up my networks. And then for network 0, I could sit here and start adding stuff up. So I got 1, and then I go up to 3, 7, you know, I can keep adding until I get up to here. So I've gotten up to here. This is still 0. I've turned on every other bit. That gets me up to 127. And then when I zero out everything and I turn this bit on, I'm starting at 128. That's my starting point. And then I start adding things on. 135, 143, 159, and I just keep going until I have everything on, which is 255. For a
Yeah,
26,
that's where it gets tough.
yeah,
start
so
adding
126. So let me take my eraser here, pin back. 126, I'm essentially saying these 2 bits I'm going to take and use for my network, and then the rest will be host. So then I have network 00. Which goes from 0 to, because I only have the last 6 bits, so 0 to 1 to 63. I turn on network 1. I go from 64 to 127. Five, I go from 128 to 191. And then the last one goes 192 to 255. Is this making sense? Where I'm basically just stealing these 2 bits and using them for my network, and then only allowing the last 6 to be host. All I'm doing is extending that classfulness into my binary a little bit, or into my class C a little bit. You guys are worrying me, you're all staying quiet.
I'm scared to say yes, that I get it.
I'm following.
So if
I'm,
it's
I'm, all I'm asking is
if
like,
it's
is it
every
start?
bit, if it's every bit of the last octet, what would that slash number be?
Well, it could go up to, the highest you can go is to /30. And that would leave you 4 bits. So you'd have the last 2 here. You have 4 possibilities, but you need 1 for the broadcast and 1 for the router. And then that leaves you 2 hosts.
Oh, so it can only be 6. You can only
So
take up
slash-
6 in the last octet?
Yeah, so 6 and the last 2 have to remain open for hosts.
Okay.
So let me,
And so
Instead of
every
this-
time you go up, it what is it, double the possibilities?
You double the number of networks you have, and then your ranges get broken down by half again.
Okay,
So
I'm starting to
we
get it
have
now.
we have 128 in each range here, and then 128 and a half is 64. So each range here is 64 hosts. So we cut it in half. So if I did a /27, so we'll do that over here.
32.
/27, yeah, we're gonna have 32 because we're gonna use 3 bits. So what are our options for 3 bits? Start at the bottom. We have 0, 0, 0,
8.
0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 different possibilities for networks. And this would go from 0 to 31, 32 to 63, 64. So what is that? To 93. Or no, it's not right. 96. 95, sorry. 96. 127.
Ellie, how does this relate to VLANs?
Well, this is how you could break up networks into smaller and smaller chunks, but VLANs is more about ports. So you would say, like, if you were working at desk 7 in an office and you transferred from accounting to HR, I could go in the VLAN and say port 7 is now part of HR, and it would transfer you without having to move your seat. I would put you on a different network without actually physically having to move you.
Okay.
So that's VLAN. But but you can also use VLANs to break things up into different networks like this. And I can assign you would be assigned different addresses as well. So 128 to 1.
There's somewhere where we did this. Like I can't remember if it's Coursera or Test Out, but I did this somewhere. They make you do this.
Yeah, it was it. Well, Coursera made you do this for the
I didn't get it, but I did it. I remember doing this.
yeah.
So it would be the 6 first numbers in the last octet in binary? Or would it be like the end of it? Would you get the end of the last octet or the start at the
160.
beginning?
Well, no, it would be the last 8. So remember, it's a series of 1s followed by a series of 0s. The 1s represent network, the 0s represent host. And I'm taking some of those host bits to create smaller networks.
Okay.
1.
Kelly, why is it 161, not 181?
4.
That's 160, not 180. I think it's
Okay, 160. My fault.
yeah.
1. I told you my handwriting's horrible.
Okay,
And I'm trying to write all this like much smaller. So
193. Okay.
So the options double. All right.
well, the number of networks double.
No, the number of network double and so say it, because I have maybe my wording is wrong. I know one side doubles like where the bit side, whatever that equate to. What is that? The networks, right?
So this is the networks,
Yes.
and then this is the ranges.
Yes. So the
So like
networks.
if I had a /27 up here, and my address was 192.168.15.136, which network, and it's a /27, which network would I be in?
126.
100.
Yes. 1. No 1. No
0,
0,
1,
1,
1.
1.
No, 100 right here.
You said 126.
Yeah, because it was 132 was my last octet.
Oh, 132.
132, yeah. So that would put me in this 128 to 160 range. So I would be in network 100. That makes sense because I
Yes.
fall in this range right here.
Yes. That makes sense.
Wait, say that again. So it's 192.168.15,
15.132,
132 slash
27.
27. Okay.
So that would be these networks right here. Here are my ranges. That 132 would fall into network 100, which has a range of 128 to 160.
Okay.
And then for sanity's sake, we never have to go above this to complete what Coursera wants. But you get the basic premise. So if I have a /28, how many networks would I have?
/28.
So one above the 27, I have a /28. How many networks would I have?
You have 16.
16.
I'd have 16 networks, right? And how big would each one of those networks be?
16.
16 hosts.
Wait, say that again. Sorry.
So we're using another bit. So if I said a 28, instead of 8 networks, I would double that because I'm adding another bit. So I would have 16 total networks. And right now I have 32 hosts in each network. I would cut that in half. So because we've doubled the number of networks, I now have 16 computers in each network.
Okay.
So each bit you add, you're doubling the number of networks and you're cutting the number of hosts in each computer or in each network in half. So /24, we have 256 possibilities. /25, we take that extra bit, we now have 2 networks, each with 128 possibilities in it, right? Move that bit one more time, we have a /26. I now have 4 networks with
Of
64 possibilities in each network. 27, I now have 8 networks with 32 possibilities in each network. You see what's happening? So
Okay.
you double your networks and then you cut your hosts in half.
So if it was 255.255.0.0, that would increase the ranges for the amount of the /27. Like it would be able to go past /30 if you did that, right?
If I did what?
If you had 255.255 .0.0, you would be able to choose for
Yes.
more bits and create
Yes,
more
yes.
networks, is what I'm saying.
Yes, but we're not going to get into that
Yeah,
because you start talking about thousands of computers per network and all that stuff. It gets to be kind of scary when you start talking about that. So we're not going to be talking about that.
Yeah, that's fine. I just wanted to know where it went
Yeah.
if you go past that.
So
Kelly, you double your network and what did you say?
cut your hosts in half. The number of hosts you can have on each network, you cut in half.
Cut your hosts in half. Okay.
Because remember, on a Class C network, we can only have 256 total options, and that's 0 to 255.
So
Right?
it's not really like it's not really a matter of the amount of your hosts getting smaller. It's just that you're dividing your hosts into groups.
Yes.
So you
essentially.
you're just dividing the same 256 bits into
Well, the
into
same
different
256
groups.
hosts into smaller and smaller groups.
Into smaller groups. So it's just like you basically have 256 square feet and you're putting rooms, and each room would have a different amount of square feet. So you have, one room, the bathroom, the bedroom, and the kitchen, stuff like that. So nothing is really changing in the network per se. It's just
Yeah.
your
Right. It's like you're just
dividing the
horning
groups.
in on your target even more.
Yeah.
So you,
So if
you
I
might
have, like-
know the
ahead.
area, now you know the street, now you know the building, now you know, like every time the numbers get smaller, you get closer and closer to your target.
Yes. Very good. And so like, but you don't have to like divide up all your networks. You can literally just do it in smaller chunks if you wish. Like I could take my 2 network servers and put them on their own little network, and then I can, you know, use everything else. And I could do a /25 for a huge portion of operations, and then break one of like the /20, the other, like, so I'll have operations being 0 to 127, and then I could take this 128 to 255 and break that into these 2 chunks here for /26. So I can break it into smaller and smaller chunks as I need to manipulate my network to fit my needs as an administrator. That's all I'm doing is making it so that I can, create and manage my networks more efficiently. That's all this is for. But are we starting to understand a little bit how it's breaking up? Like the IP addresses, are we now looking at that network tree that you had to do at the end of week 2 for bits and bytes? Are you starting to see when you saw that /26, this is what they were talking about. So you could tell if they were in the same network or not. They were talking about your network ranges by using that last octet. We want to do some examples and work with it a little bit.
Yes, please.
All right. So that goes away. All right. So I'm going to drop an IP in chat. Tell me what network that falls in and what the range is of that network.
Can you break it down just like you did the last one? Just so, is there a way someone can do that?
Well, we will do that once we get the answer, but that's why we're setting it up for you so you guys can do that. I want
And
you to be able to find
the
the
IP is
ranges
not
and work.
complete. The
Sorry,
IP
what was
address
that?
is not complete. It's not complete. It's just 3 octets.
Oh, it's not. Oh, it's still 3.
Yeah.
Oh, my apologies. Let me
Kelly,
redo this here.
I know what I'm doing. I just
192, 168, dot 15, dot 113 /25. There we go. Sorry about that, SK.
all right. Kelly,
Yo,
can you just answer? I mean, ask the question again. I just need to hear it so I could. So I know
what
the
I want to
answer.
know on this one is what network this would fall in, and what would the range be on that network? All right, Christine, 0 to 126, 127, very good. So binarily, what would that network look like in the binary? So would that be network 0 or network 1? 0, there we go. So that's going to fall in network 0. And the range for that network is going to be 0 to 127.
Good question. Where did that 127 come from? I'm so sorry.
Because that's if you take 256 and cut it in half, what's the number?
128?
128, right? So 0 takes up a spot. So that's 0 to 127 gives you 128 spots, right?
Wait, so it was 113/25, right?
Yes,
So, did we use 113 or did we 13 or 3?
113 is going to be the indicator of which network you're in, and the /25 tells you what CIDR notation. That's the CIDR notation. That's /25.
Mm-hmm.
That lets you know that I'm not using a standard class C routing. I'm using what's a subnet routing, a CIDR routing. So I have a /25, which means I'm using an extra bit
So
for
one
my
bit.
networks.
Yes.
Because instead of 24, I'm using 25. So 1 bit, which means, I use one extra bit for my network. And then the only ranges I had were 0 to 127 and 128 to 255. So that's 2 networks with those ranges. Right? Yes, Ramon.
Yes.
The loop back doesn't apply to this.
Well, the loopback would be the first octet. So it's like 127.0.0.1, right? We're only playing around with the last octet, so the 127 is not an issue in this
Right.
network.
Okay, I see.
Good question, though. Good question. All right. Are we ready to try another one? All right. So go.
So 26 is 2-bit.
Great. I don't have much for you.
Work it out. I think you can get it, Ninja. We'll give everybody about a minute. I'm going to pause the recording real quick.
So that should have gone through. I'll see if it gets processed. And